Hello everyone, it's question 8 on paper 1 from 2023, and what have we got? We have got like a radians modelling kind of question. So it says question 8, figure 1 shows the plan view of a stage. The plan view shows two congruent triangles, ABO and GFO, joined onto a sector OCDEO of a circle with centre O, where the angle COE is 2.3 radians, the arc length CDE is 27.6 meters, and AOG is a straight line of length 15 meters. Show that OC is 12 meters. Okay, so here's our stage. Now I think the idea is that this is the audience out here, and this is the front of the stage like that, and this is backstage. Okay, and this is the side of the stage. So first of all, we've got to show that this length, O to C, is 12. Well, the formula for the length, arc length, is equal to r times theta when we're working in radians. So L is equal to r theta. Okay, so given that that's the case, we have got the L is 27.6. We've got the theta is 2.3 radians, so therefore we can work out what r is. So 27.6 times by OC is 2.3. So when we divide by 2.3, we get what OC is, and that turns out to be 12 as required. So that's part A done. Part B, show that the size of the angle AOB is 0.421 radians correct to 3 decimal places. Okay, so we have a straight line at the back of the stage here. So this is AOG here, AOG. So the two triangles, remember, are congruent. So the angle here is the same as the angle here. So I've just basically said that that is theta and theta. So what we've got is a straight line, which is pi radians minus 2.3 divided by 2. And that's going to give us our angle theta, which is 0.4207. But when we give that to three decimal places, that is 0.421 as required. So that's part B, quite nice for 2 marks. Now, the next bit, given that the total length of the front of the stage is equal to 35 meters, find the total area of the stage, giving your answer to the nearest square meter. So the front of the stage, so this one, add this one, add this one. Okay, so that, add that is equal to 35. So I've just called it, for the sake of argument, x, the length BC, which is the same as the length EF. So we have x add 27.6, because remember that's 27.6 there, is equal to 35. And from that we can work out what the x is. So 2x is 35, take away 27.6, and x is therefore 3.7. Now, if this length here is 3.7, remember this is 12, so it means that from O to B is going to be 12 add 3.7. So O to B is going to be 15.7. And that's going to be the same for O to F, because those two triangles are congruent. So therefore, the area of the triangle, this one here, triangle AOB, is going to be using half AB sine C. This length here is going to be 15 over 2. This length here is 15.7. And that angle there was our 0.421 that we calculated a moment ago. So our triangle has an area of a half times by 15 over 2 times by 15.7 times by sine of 0.421, which gives us 24.06. So we're going to have two lots of 24.06 there, one there and one there. And we just now need to find this bit here in the middle. The formula for the area of a sector, when we're measured in radians, is a half r squared theta. So it's going to be a half, and remember that our OC, from the beginning of the question, earlier in the question, this length here, OC is 12. So we have a half times 12 squared times the angle, which is 2.3, plus 2 times our 24.06. And we work that out, that comes to be 214 meters squared when given to the nearest square meter as the question's asking. Quite a nice little question there, but they all tend to be pretty much like that, to be fair. I hope you found that helpful, and I'll see you in the next video.